In this video, we are going to be working on permutations and combinations. The examples for this video are kind of an introduction to permutations and combinations. Looking at this first one, we have Holly, Tia, Kenji, and Nate are eligible to be officers of Honor Society. 2 of the 4 students will be chosen at random as president and vice president. The table summarizes the possible outcomes. Holly wants to be an officer with her best friend Tia. How many outcomes make up this event? So looking at this, we have the possibility of Holly being president and Tia being vice president. We also have the possibility of Tia being president and Holly being vice president. So there are 2 outcomes that work here. How many outcomes show Holly as president and Tia as vice president? There's only one option for Holly being president and Tia being vice president. How many outcomes have only one of them as an officer? So we're going to look through this chart and see how many we have where only one is an officer. So Holly is president here. And then we have Tia being president. So now we're up to 4. And then we also could have Holly being vice president. So that's 6. And then Tia being vice president. That is 8. So there are 8 possible outcomes that have only one of them as an officer. So let's go through this example. We are talking about the counting principle here. We have Manuel, who wants to advertise the number of 1-topping pizzas he offers to his customers. How many different 1-topping pizzas are available at Manuel's Pizzeria? We have his menu right here. You have the option of choosing a large or a medium. With the large, you could get either a deep dish pizza or a thin crust pizza. Same thing with the medium. We could get a deep dish pizza or a thin crust pizza. Then on those different types of pizzas, we could get sausage, pepperoni, or cheese. On the thin crust large, we could also get sausage, pepperoni, or cheese. Same thing with the mediums. Sausage, pepperoni, cheese, sausage, pepperoni, cheese. If we count up the different types of pizzas, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different types of pizzas. Now this would be intense if we had to do this every single time. So I want you to keep on the lookout for a pattern between the options we're given. We were given 2 sizes, 2 different types of crust, and 3 toppings. So keep that in mind, keep our answer in mind. If you already see the pattern, awesome. If not, we're gonna go onto another example and see if you can figure out the pattern here as well. So we have the car that Miss Garcia is buying comes with a choice of 3 trim lines, standard, sport, or luxury, 2 types of transmissions, automatic or manual, and 8 colors. How many different option packages does Miss Garcia have to choose from? So we have Miss Garcia, she's buying a car, and she could buy a standard, she could buy a sports, or she could buy a luxury car. And of those options, she could choose to make the transmission automatic or manual. So all of these are automatic or manual. And then she has her color options. Her color options, there's 8. So we're not given 8 different colors to write down, so we'll just separate 8 lines here. So there's 8 here. There's 8 colors for the manual. There's 8 colors for the automatic sport. 8 colors for the manual sport. 8 colors for the automatic luxury, and 8 colors for the manual luxury car. So if we count up how many 8s we have 1, 2, 3, 4, 5, 6. So that's 6 times 8, which gives us 48. But again, let's think back to what options we had. We had 3 different types of cars. We had 2 different types of transmissions. And then we had 8 colors. So we can get the same thing by taking 3 times 2 times 8, and we still get 48. We could have done that in that first example as well. We could have taken 2 times 2 times 3, which equals 12. So we can continue on, or you guys can continue on your own and try examples of the counting principle.